Welcome to my brief video on learning how to add and subtract integers, including negative integers. So I'm going to do this three different ways using circles, or you could use bingo chips, or any kind of other manipulatives that you want. I'm going to show the same thing with number lines, and then one more time using just direct symbols and try to connect all of the ideas for you. So for starters, I'm going to be, as I'm drawing this, I'm going to be using circles that could represent chips. And my dark circles are going to represent a positive 1, and my red circles are going to represent a negative 1. And this is a really important idea. Whenever you are going to our first problem, 5 plus 3, we already know the answer, but let's sort of build up for a later idea here. Whenever you are adding, you put into a pile, and whenever you are subtracting, you take away from a pile. And it's really that simple. I think that's probably pretty intuitive for most of you. Whenever you add, you put in, and whenever you subtract, you take out. So what would happen if I had 5 plus 3? Well, I've already got 5 chips, and I add 3 more, so there's 1, 2, 3 more chips. Altogether, I can see I have a total of 5, 6, 7, 8. Total of 8 chips, so 5 plus 3 must equal 8. So what would happen if instead I subtracted 2 chips? Well, that's not bad. I've got 5 chips there. If I take away 2 of the chips, then I can see that what remains are 3 chips, so 5 minus 2 must equal 3. Adding puts in, subtracting takes out. All right? So this is really important idea here. We talked about the dark circle being a positive 1, and we talked about the red circle being a negative 1, and they're really just opposites. They cancel each other out. So whenever I have a positive 1 and a negative 1, that's going to be a 0. And I'm going to use that a lot in the next few problems. So what if I have 3 minus 4? I want to take away 4 chips. But there's a problem. Subtraction, so I take away. But there's a problem. There's only 1, 2, 3 chips. I don't have 4 to take away. So here's how I solve that problem. I can always put in a 0, I can add in nothing, and it doesn't hurt me. So I'm going to put in, I don't have enough chips, so I'm going to put in a positive and a negative. Altogether, I just added in 0. I put in 1 positive, 1 negative, that's a 0, but now I have 4 chips that I can take away. When I take away all of those, I'm left with 1 red. So my result is a negative 1. 3 subtract 4 is a negative 1 because there was a negative 1 chip left over when I removed the 4. Adding in a 0 gave me a way to take away from the pile in the way that I wanted. So remember, adding always puts into a pile. Subtracting always takes away. And we're going to make a lot of use of 0. And remember, a positive 1 and a negative 1 together give us a 0. So I will do that. I will put in zeros and take away zeros as much as I need to. So what about 5 plus negative 2? Well, in this case, I have an addition, so I'm going to add to this pile. And what am I going to add? 2 negatives, so I'm going to put in 2 negative chips. Now notice, every time I have a positive and a negative, that's a 0. So I will remove those, and then I will remove another 0, so that I'm down to just a single kind of chip left over. And I notice after I do this, there are 3 chips left over, so 5 plus negative 2 must be a 3. It was an addition. Add in the chips that you need. Knock out your zeros. In the previous problem, I put in a 0. This time I took out some zeros. No problem. How about 5 minus negative 2? Well, I've got 5 chips, and it's a subtraction problem, so I need to remove from the pile. But what I need to remove are 2 negatives. I don't have any negatives. Not a problem. If I don't have anything, then how about I put in a 0. Well, now I've got 1 negative. I need to take away 2 of them, so let's do that again. Let's put in another 0. Now I have the 2 negatives, My problem said take away two negatives, so there's my two negatives. When I remove them, I can see that what remains are 5 plus 2, or 7 chips. So 5 minus negative 2 must be a 7. So it's really not that bad. Whenever you have addition, put in whatever it says, positives or negative chips, and whenever it says subtract, take away. And when you have zeros left over, you can cancel them out. And if you need to make up the amount that you need to take away, feel free to add in as many parts of zero that you need to until you get the part that you need to take away. So let's now play this same idea on a number line. If I knew 5 plus 2, well, on a number line that says my first number is 5, so let me start at 5. And we know 5 plus 2 is 7, so I know I'm going to end up over here, and notice that when I did addition, I moved 2 spaces to the right to get to my answer. For subtraction, 5, and we already know 5 minus 2 is 3, so this time I'm going to move to the left to subtract. So addition and subtraction can be thought of on a number line as just addition moves me to the right and subtraction moves me to the left. But then some weird things started to happen when we were playing with negatives. And in our previous problems, we saw 5 plus negative 2 right up here. 5 plus negative 2 was a 3. So that says, starting with 5, which is where I'm starting on all of these problems, and I want to add negative 2, I'm going to end up at 3 according to my work with the chips. So adding a negative 2 moved me left 2 units, not right 2 units like I thought. But notice that looks a whole lot like the subtraction problem that I just did before. So adding a negative is just like subtracting. How about the last problem? 5 plus negative 2. Well, I know I'm starting at 5. That was my starting number. Let's look back at what happened before. 5 minus negative 2, the answer was 7. So let's plot that on the number line. There's my 7. So I started at 5 and I ended at 7 when I subtracted negative 2. So this time, that number line looks a whole lot like what happened up above when I did 5 plus 2. So subtracting negative 2 is just like addition. Adding negative 2 is just like subtraction. So the big overall story that we can tell here is when you add and subtract positive numbers, adding moves me right, subtracting moves me left. But it seems like whenever I am adding or subtracting a negative number, I do the reverse of whatever I would normally do. So 5 plus says I move right, but it's a negative 2, so I'll actually move left 2 units, and there's my answer of 3. 5 minus, that minus says I should move to the left, but it's a negative number, so I'll reverse that and actually go to the right 2, and there's my 7. If you like the chips idea, that's awesome. If this number line and sort of moving back, thinking of adding and subtracting is moving along a number line, if that makes more sense to you, then you ought to try it that way. In the end, what I hope all of you will end up at is this whole idea of sort of symbol manipulation. Can we get away from all of the pictures and the number lines? And if we need them while we're learning, that's great. But in the end, you'll just be a whole lot faster if you think of this as 5 plus a negative. Remember from our number line, 5 plus a negative is the same thing as subtracting. Doing something with a negative reverses the operation, and 5 minus 2, I already know the answer. 5 minus, okay, there's another negative, so it reverses my operation, just like what happened with the chips and with the number line, and 5 plus 2 is 7. So you can turn all of these symbols into something that's a whole lot faster. If ultimately you understand the symbols, then you just have a much faster way of solving the problem. I hope this helps.